Hi guys, today we're going to have our new topic in math, so which talks about geometry. But before that, please don't forget to hit the subscribe button and the notification bell for more videos, for more educational videos about math. Now, we will be talking about axiomatic structure of geometry. Alright? So these are mostly statements or axioms that talks about geometry, and these are the basis why a specific concept in geometry exists. So in this specific topic as well, we are going to learn on how to reason out and how to convert statements. Okay? Now, before that, so this session will cover the following: brief introduction to geometry, types of reasoning, and types of statements. Alright, so these are the things that we're going to have today. Then, so before that, let's have our activity. So that before we actually talk about a brief introduction to geometry, we are able to have our idea. Alright, so number one, who is the father of geometry? So which do you think is who is rather the father of geometry? Letter A, the elements; B, Euclid; C, inductive reasoning; D, geometry; E, deductive reasoning. Alright, very good. It's letter B, Euclid of Alexandria. He is actually the father of geometry and the founder of Euclidean geometry. Alright, so let's have number two. It can be translated as Earth's measurement. Alright, so when you are still in elementary and even in lower years of high school, okay, so you are able to talk about the origin of this branch of math. So the answer in this question is what? It's geometry. Okay, so it means Earth's measurement. It was derived from two words, geo and metron. Geo means Earth, and then metron means to measure or measurement. So if we're going to combine, it means Earth's measurement. For number three, it is known as the most influential and widely used geometry textbook. It's not actually simply a textbook, it is a combination of 13, it is a compilation rather of 13 books written by the father of geometry, no other than Euclid of Alexandria. So the answer here is the elements. So in this book, we are able to encounter different postulates and theorems that are actually being used today in geometry. Okay, so the title of the books, the elements. Alright, so number four, it is a kind of reasoning that takes specific examples and makes a conclusion out of them. Alright, so it means if we're going to simplify the definition, it means from specific to general. Alright, so you're not going to deduct something, but you will take specific situations or statements to general. You will generalize them. So the answer here is inductive reasoning. Okay, for number five, it is a kind of reasoning that apply general statement to specific situations. So the answer, of course, is deductive reasoning. So it is the other way around, from general to specific situations. Alright, next, what is geometry? So geometry is a branch of math that deals with shapes or figures and measurement. So if you're going to turn around right now, you will be seeing a lot of figures and shapes. Okay, so we're in if those are man-made, okay, so there's an application of geometry to construct those. Alright, next, geometry. Geo means Earth, metron measurement. So if we are going to combine, Earth's measurement is the meaning of geometry. Then, Euclid of Alexandria is the father of geometry and the author of the Elements, compilation of 13 books. And the kind of geometry that we are studying right now in high school is Euclidean geometry. Why? There are a lot of types of geometry that we might encounter in our higher years, not only the Euclidean geometry that we know in high school. Alright? Next, application of geometry is mostly in architecture, engineering, arts, and carpentry. Alright, so and many more. There are a lot of disciplines wherein we can apply geometry in different disciplines. Alright, next, geometry is mostly consists of writing proofs, proving statements and theorems, and reasoning. Alright, so it means class in geometry there are what we call postulates and there are what we call theorems. So when we say postulates, these are universally accepted as truth. So it means we don't need to prove this. They are already accepted. We are using these postulates as proof now for um, theorems. When we say theorems, it means we need to prove them before we accept them as fact. Those are two different things, alright? So, writing proofs, proving statements and theorems, and of course, reasoning. So, first, let's have the types of reasoning. First, determine the next figure in the following series. Of course, maybe we have a sequence here. We have north, we have northwest, we have west, we have southwest, we have south. What do you think is the next term of the sequence? Alright, very good. It is southeast. So, but in geometry class, we're not going to accept easily that the last term is southeast. We have to prove, we have to find a pattern so that we can say that the answer is southeast. In this specific example, we can say that we use the counterclockwise direction. Okay, so in identifying, alright, so the next term of the sequence. Next, fact. It means if it is a fact, it is like a postulate, we will be accepting it as true statement. All multiples of 2 are even numbers. Question is, which among the given numbers is not multiple of 2? Letter A, 12, B, 0, C, 739,286, or D, 253. Alright, so analyze the choices and of course the question. And you have to answer based from the fact that all multiples of 2 are even numbers. Okay, so what do you think is the answer? Very good. It is D, 253. Why? Because we can actually say that since 253 is not an even number, it's an odd number, okay, we can say that it's not a multiple of 2. Alright? So what is the other reason? Because of the fact that all multiples of 2 are even numbers. The type of reasoning is inductive reasoning. So when we say inductive reasoning, class or guys, it is a kind of reasoning that takes specific examples and makes a conclusion out of them. Alright, so it is what we call bottom-up approach. When we say bottom-up approach, we are taking specific situations to general. So based on the specific situations or statements, we will now generalize them into one which is applicable for all or sometimes not. Okay? So just take note of this, of the definition specific to general. In mathematics, it is used to test patterns, ideas, and form conjectures or generalizations. So it means we are talking about patterns. So if you're going to take an entrance exam in a college or any school, you can see actually you are going to encounter actually patterns. Alright, so we're in, okay, you have to give the last term and so on and so forth. Those are under inductive reasoning. So the general statement, okay, that we might get from those specific statements or sequence is what we call conjecture. When we say conjecture, guys, it is an idea that results from patterns derived from observations. So it means the general statement, I repeat, is what we call conjecture. Alright? Next, example. Let us analyze the following triangles. We have triangle ABC, triangle DEF, and then triangle ILM. So form a conjecture based on the observations. Alright? For number 1, the sum of the interior angles of triangle ABC is 180 degrees. So it means, how did we know that it's 180 degrees? Let's add the angles. It's 45 degrees plus 65 degrees plus 70 degrees. So the sum is 180 degrees. Next, case 2. The sum of the interior angles of triangle DEF is 180 degrees. Alright, so add them. 60, this is a right triangle. Therefore, if the other measurement is not present, it is automatically based on the structure. It's 90 degrees. 60 degrees plus 90 degrees plus 30 degrees is equal to 180 degrees. Next, case number 3. The sum of the interior angles of triangle ILM is 180 degrees. So just add 60 plus 60 plus 60. you will be getting 180 degrees. So this, we are now in the inductive reasoning. These are the specific statements that we have. So based from this specific statement, we have to form our conjecture. So therefore, the conjecture that we can make here is that the sum of the interior angles of a triangle is 180 degrees, which is true. Why? Because we cannot call it a triangle if the sum of its angles is not 180 degrees. It must be 180 degrees. That's why the conjecture is true. Alright, so see, from the cases, which are the specific statements, to general, which is the conjecture that we have made. Next, example. Square, a quadrilateral has 4 sides. Rectangle, a quadrilateral has 4 sides. Parallelogram, a quadrilateral has 4 sides. Okay, so these are the specific statements. Therefore, we can say that the conjecture is all quadrilaterals have 4 sides. It's true. Why? Because a polygon with four sides is what we call quadrilateral. All right. So it means the conjecture that we are able to construct is true and applicable for all. It doesn't matter if it is a rhombus, if it is trapezoid, trapezium, and so on and so forth. For as long as it has 4 sides, it is what we call quadrilateral. Okay. Next, Ricky says, my math teacher is a male. My English teacher is also a male. So what is the conjecture that we can make based from the statements? That all teachers are male. But this is false. Why? Because there are also teachers that are female. Why? A conjecture is true. Take note of this. A conjecture is true if it is true for all cases. A conjecture is false, however, if you find a counterexample that disproves the conjecture. So it means, class, it's not all time that a conjecture is true. Sometimes it becomes false if if there exists a counterexample that will disprove it. In this case, all teachers are male. The counterexample that we can actually give based from this is that there are also teachers that are female. Okay? So, it is still the conjecture, but it is false because of the counterexample. So when you actually make an argument, so if you think that there is a counterexample that will disprove the idea of others, you can actually say that. Okay? Next, guess the missing number. A 13579. What do you think is the next number? Very good. It is 11. Why? The conjecture is that because the numbers are consecutive odd numbers, then the next number is 11. Also notice that the difference between succeeding and previous number is 2. So add 2 to get 9, add 2 to 9 to get 11. So, if you're going to ask me, teacher, can we apply any other conjectures that is true for this specific pattern? Of course. Okay? Of course, you can. These are just some of the conjectures. So, but if you actually find another conjecture which is the pattern or which is applicable for this sequence, it's fine. There's no problem with that for as long as that it is true for this. Okay? Next. 2, 4, 8, 16, 32. What do you think is the next number or next term of the sequence? Very good. It is 64. Solution is that the numbers are powers of 2. 2 raised to the first power is 2. 2 raised to the fifth power is 32. Therefore, 2 raised to the sixth power is 64. So if you're going to say, oh, you are multiplying by 2 so that you get the next term, there's a common ratio which is true. 2. Is that also applicable, teacher? Yes. Okay, so 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. So it means that conjecture is also correct. But if you will say, oh, teacher, you are doubling the previous term to get the next term, is that also correct? Of course. 2 plus 2, 4 plus 4, 8 also. It's correct. Okay? So there are, when we are talking about number pattern, we can actually apply different, or we can actually state different conjectures that will be applicable for that specific sequence. Alright? Next, deductive reasoning. So remember, for inductive reasoning, it takes specific situations or statements to general. Alright? So now let's have deductive. When we say deductive, class, what is deductive? It's the opposite of inductive. So if in inductive it's from specific to general, in deductive it's from general to specific. Just remember that it is what we call top-bottom approach or general to specific. Alright, so there's a general statement, okay, and then after that you will actually state some specific examples based from the general statement. So that is deductive. Example, all numbers ending in 0 or 5 are divisible by 5. That is general. Now you will be giving an example. The number 35 ends with a 5. So you can now generalize or conclude. Therefore, 35 is divisible by 5. Alright, so the statements in blue font color are what we call the premises. Okay, premises here contains the general plus the specific example, and the red part is what we call the conclusion. That's it, from general to specific. Next, all birds have feathers. Parrots are birds, therefore parrots have feathers. So all birds have feathers and then parrots are birds. Okay, so these are what we call premises, while the conclusion is therefore parrots have feathers. From general to specific. Alright. Again, the difference between inductive and deductive, when we say inductive, it's from specific to general, while deductive, it's from general to specific. Now, let's have the last part of our session, types of statements. Let's begin with conditional statements. What is a conditional statement? In math or mathematics, so maybe in grade 7 you are able to encounter the if then statement. It is what we call conditional statement. It is what we call conditional statement. Example, if you study hard, then you will be getting high grades. This is true, right? So if you're not going to study, of course you're not going to you're going to get good grades. But if you will study, of course you will be getting good grades. Okay, so that's it. That's the idea. Next, these are some of the examples. This might be the who got examples that I can give you. If loving is a sin, then it is my favorite crime. If a friend talks behind your back, then he is not a true friend. If someone always gets your attention, then he has a secret crush on you. Maybe this is not true for all. Okay? So you might be misunderstanding that the person is that the person's attitude is like that. So to get the attention of everyone, do not assume that he has a or she has a crush on you. So at the end, you might he might broke or she might break your heart. So if you will crush him or her back, okay, do not assume. Next, if someone laughs even at small things, then he is lonely inside. So maybe this is applicable for some. Why? Because if you're going to observe the people who are always happy when you see them, who are always laughing when you see them, inside their heart, they are actually emotionally challenged. They are experiencing something deep. Alright, so all we need to do is to care for them and be with them in their tough situations. Next, finally, if you love someone that don't love you back, then you must set her free. If you love someone that don't love you back, then you must set her or him free. Alright, so this is really important. In Filipino, huwag kang mamalimos ng pagmamahal. If that person does not love you, set him or her free. Remember, you have to love yourself first before you love others. Okay? So you can learn to love others if you love yourself. And you have to make sure that specific person loves you. If not, set him or her free. There is someone that will come into your life that will give you more than what you expected. So the if part is what we call the hypothesis, while the then part is what we call the conclusion. So in identifying the hypothesis and the conclusion, just remove if and then. Then you can state that specific statement or sentence after if or after then. When we say hypothesis, these are statements that needs to be proven based on scientific facts and so on. Alright, conclusion, that is the one that will prove the hypothesis. If the square root of a number is a whole number, then it is a perfect square. So let's identify the hypothesis. The hypothesis here is the square root of a number is a whole number, while the conclusion is it is a perfect square. If the measurement of the angle is 45 degrees, then it is an acute, acute angle. So the hypothesis, the measurement of the angle is 45 degrees, and the conclusion, it is an acute angle. If two lines intersect and form angle with which is 90 degrees, then they are perpendicular lines. The hypothesis, two lines intersect and form angle which is 90 degrees, and the hypothesis or conclusion is they are perpendicular lines. If a segment is twice the radius, then it is a diameter. The hypothesis is a segment is twice the radius, and the conclusion, it is a diameter. If a triangle is isosceles, then it has at least two congruent sides. Okay, remember to remove if for the hypothesis, remove then for the conclusion. The hypothesis is a triangle is isosceles, and then for the conclusion, it has at least two congruent sides. Now, we're done with the conditional statement. Now, we are going to convert conditional statement to converse statement, inverse statement, and contrapositive statement. So what's the difference between the three? Let's start first with converse. The converse of a given conditional statement is the result of interchanging the hypothesis and conclusion of the given conditional statement. So it means we will be changing the places of hypothesis and conclusion so that we will be able to get the converse of the conditional statement. Example, if an animal is a frog, then it is an amphibian. This is the in symbol, it is P implies Q, or if P then Q. So P being the hypothesis and Q being the conclusion. The hypothesis is a frog, and then the conclusion is an amphibian. Just interchange those. And remember that after the if part, you're not allowed to use pronoun, rather you will be using proper noun or noun. Okay? Converse. If an animal is an amphibian, then it is a frog. See, we interchange the place of is a frog and is an amphibian. That is already the converse. So you are only allowed to use noun in after if, and then pronoun after then. It is the pronoun. It's now Q implies P, or Q then P. If two angles add up to 180 degrees, then they are supplementary. So the converse now, if two angles are supplementary, then they add up to 180 degrees. Just interchange them. When we are converting conditional to converse, remember to just interchange the hypothesis and conclusion, or the P and Q. If a polygon has 6 sides, then it is a hexagon. Converse, if a polygon is a hexagon, then it has 6 sides. Just interchange. Reminder, this is what I have said a while back. Avoid using pronouns in hypothesis. So given the statement, if an animal has mammary glands, then it is a mammal. You're not allowed to make it like this. If it is a mammal, then that animal has mammary glands. That's wrong. So what you have to do is that retain the noun. It is now, if an animal is a mammal, just move the predicate but not the noun or the subject. If an animal is a mammal, then it has mammary glands. That's the correct one. Now, let's talk about inverse. Just remember, for converse, just interchange the hypothesis and the conclusion. Now, let's have the inverse and the contrapositive. When we say inverse of a statement is a result of negating, we will be negating. So, we will be using not. Negating the hypothesis and conclusion of a conditional statement. Whereas, a contrapositive is a statement that comes from both negating and interchanging. Again, in converse, interchange. In inverse, negate. But in contrapositive, you will do both. Interchange and negate. Okay? Next, this will serve as your guide whenever you convert statements. Converse, inverse, and contrapositive. Given the conditional statement, if P then Q, the converse will be if Q then P. You will be just interchange. And then the inverse is if not P then not Q. Just negate both the conclusion and the hypothesis and conclusion of the conditional statement. Then therefore the contrapositive is if not Q then not P. You will do both interchanging and negating. Alright? Example, conditional. If an animal is a frog, then it is an amphibian. The converse interchange, if an animal is an amphibian, then it is a frog. Inverse negate, if an animal is not a frog, then it is not an amphibian. Then contrapositive, if an animal is not an amphibian, then it is not a frog. Alright, so did you see the difference between the three? In converse, we just interchange. In inverse, we just negate. And then in contrapositive, the basis statement is always the conditional statement, guys. Not the converse, not the inverse, not the contrapositive. So the conditional statement is the one that you are converting to converse, inverse, and contrapositive. Alright? So, find out if the statements are true in your examination. Of course, you have to, other than converting the statements, you have to also find out if true or false. If an animal is a frog, then it is an amphibian. That is true. Of course. So, frog is under the species of amphibian, cold-blooded. It means they can be on land and they can be also on water. Converse, if an animal is an amphibian, then it is a frog. So there are a lot of species of amphibians, not only frog. That's why this is false. If an inverse, in inverse, if an animal is not a frog, then it is not an amphibian. Again, there are a lot of species of amphibian, not only frog. That's why this is false. For contrapositive, if the conditional statement is true, therefore the contrapositive follows that it is also true. Okay? Excuse. Conditional. If a triangle has an obtuse angle, then it is an obtuse triangle. Converse, interchange, if a triangle is an obtuse triangle, then it has an obtuse angle. Inverse, if a triangle does not have an obtuse angle, then it is not an obtuse triangle. Contrapositive, if a triangle is not an obtuse, then it does not have an obtuse angle. So find out if the statements are true or false. Okay, so you cannot call a obtuse triangle an obtuse triangle if it doesn't have obtuse angle. So that's true. Converse is also true. If the converse is true, the inverse will follow. It's also true. Then contrapositive is also true. Note, if a statement is true, its contrapositive is also true. Moreover, if a converse, so remember that if a statement or the conditional statement is true, the contrapositive is also true. So that you will not think deeper in the contrapositive. If the conditional is true, the contrapositive follows. Moreover, if the converse is true, its inverse is also true. Even if the statement is true, its converse has the possibility of being false, just like the frog a while back. If a statement and its converse are both true, then they can be joined into a single statement called biconditional statement. When are you going to write biconditional statement? If and only if the conditional statement and the converse statement are both true. If one of those is false, therefore you're not allowed to use you're not allowed to convert the conditional to biconditional statement. Combining the conditional and its converse will result in a biconditional statement. To combine the statements, you use the phrase if and only if, abbreviation, or as IFF. Just remove the if then of the conditional statement, and at the middle you just put if and only if or the IFF. It denotes that it is a biconditional statement. Conditional, if a triangle has an obtuse angle, then it is an obtuse triangle. This is true. Converse, if a triangle is an obtuse triangle, then it has an obtuse angle. So if the conditional and converse are true, therefore the inverse and the contrapositive are also true based on the note a while back. Alright, so we can now write the biconditional. Just remove, okay, the if then. It will now become a triangle has an obtuse angle, comma, if and only if it is an obtuse triangle. That's it. Next, conditional. If a polygon has 5 sides, then it is a pentagon. Converse, if a polygon is a pentagon, then it has 5 sides. Both statements are true because a polygon with 5 sides is what we call pentagon. The inverse we will negate. If a polygon doesn't have 5 sides, then it is not a pentagon. Contrapositive, negate and interchange. If a polygon is not a pentagon, then it doesn't have 5 sides. Finally, since the conditional and converse are both true statements, we can write it. A polygon has 5 sides if and only if it is a pentagon. Next, conditional. If two lines extend and never meet, then they are parallel lines. Converse, interchange them. If two lines are parallel lines, then they extend and never meet. Inverse, if two lines extend, we are going to negate now. If two lines and extend, supposedly this is not never meet. But since they are two negatives, two words that are negative, you have to omit one. So in math, okay, just remove. So negative times negative, it will become positive. Same thing here. If two lines extend, rather than writing it not never meet, so you can write if two lines extend and meet, because it became positive now. You're not allowed to use double negative words. Then they are not parallel lines. Contrapositive, if two lines are not parallel lines, then they extend and meet. Alright? Finally, since conditional and converse are both true that parallel lines will never meet, two lines extend and never meet if and only if they are parallel lines. Okay, so we're done. Alright, so if you do have questions and clarifications, you can actually comment down. Or you can actually send me a personal message on my messenger. Alright, converse, inverse, and contrapositive. This will serve as your guide. If P, then Q for conditional. Converse, if Q, then P. Inverse, if not P, then not Q. Contrapositive, if not Q, then not P. That's it for today. We are able to have a brief introduction to geometry, types of reasoning, deductive, inductive, statements, conditional, converse, inverse, contrapositive, and biconditional. Alright? So I hope that you have learned a lot in this session. Okay, thank you so much for being with me, and thank you so much for watching. And of course, I would like to thank all the subscribers who are always supporting me. Then for those who are not, please don't forget to hit the subscribe button and the notification bell for more videos. Alright, so thank you for listening and have a great day. This is Teacher Dong. Thank you so much.